All right, I want you to picture this. It is the year 2126. You wake up, look out your window, and instead of a sunrise, you watch the Earth rise. You grab your coffee, step onto a monorail, and head out to your daily job. And what is that job? Well, you're rewiring massive solar panels that keep your city, Luna Prime, alive. And you're inspecting ancient radioactive heater units out on the icy lunar surface. Now, I know that sounds like this incredibly epic sci-fi adventure, but the reality? The reality is that every single second you spend outside those city walls is absolutely perilous.
So it brings up a pretty intense question. Could you actually survive the most lethal environment humans have ever faced? I mean, living on the moon means you're existing without any natural overhead shelter in a highly treacherous place. Every job up there is dangerous, and humanity has had to overcome a staggering number of deadly threats just to keep this city's pulse from flatlining.
You know, people often point to Antarctica as the ultimate extreme environment. But let's be real. Antarctica, as absolutely freezing as it is, at least gives you breathable oxygen. The moon is a completely different beast. First off, zero oxygen. Then you've got the temperature swings, which are just violently extreme. We're talking baking at 127 degrees Celsius in the direct sunlight, and then instantly plummeting to negative 73 degrees the second you step into the shadows. Plus, because there's basically no atmosphere or magnetosphere, you have zero protection from the sun's radiation. A sudden solar flare could literally shred your DNA to ribbons. Oh, and I haven't even mentioned the micrometeorites. These are tiny little space rocks flying faster than a sniper bullet, easily capable of punching a hole right through an oxygen tank or, well, your helmet.
So you're probably wondering, why on Earth, or actually, why on the moon, would anyone go through all this trouble and immense danger just to build a city there? The answer really comes down to one simple number, 16%. That is the moon's gravity compared to Earth's. Launching a rocket from Earth is just incredibly punishing physics. To reach low Earth orbit today, a rocket has to hit speeds of 35,000 kilometers per hour. And to get moving that fast, a massive 90% of the rocket's entire weight has to be pure fuel. It's a huge gravitational trap. But that 16% gravity, it mathematically changes everything. Because the moon's gravity is so weak, launching a rocket from the lunar surface is 84% easier. So the core logic of building this lunar base is that it essentially transforms the moon into a gateway for the rest of the universe. Staging a flight to Mars or the asteroid belt is hundreds of times easier if you can start the journey with a full tank of gas right from the moon. And with no atmosphere in the way, entirely new launch technologies suddenly become feasible. We're talking things like electromagnetic railguns that can just literally accelerate a payload straight into orbit. How cool is that? But okay, to run those massive railguns, and honestly just to survive the brutal 14-day-long lunar nights when your solar panels are completely useless, the city needs absolute, bulletproof power stability. And all that heavy lifting? It comes down to one absolutely crucial mineral, graphite. It is highly conductive, chemically resilient, and incredibly temperature stable. Graphite is the critical technological enabler here. It acts as the beating heart of these massive lithium-ion battery networks. It's what takes generated energy and turns it into stored life, making sure the city literally doesn't freeze in the dark.
In fact, graphite is baked into pretty much all the most essential lunar systems. It stabilizes the grid-scale energy storage, it powers the AI data centers that are actively managing your oxygen and heat, and it maintains those stable deep space communication links back to Earth. And what's really interesting is that the foundation for this kind of off-world survival is actually being built right now down here on Earth. For instance, Nouveau Monde Graphite, or NMG, is currently building a 30,000-ton per annum low-carbon supply chain using hydropower. They're partnering with giants like Panasonic and Traxys to become the G7's largest producer. So the extreme material challenges we're going to face in space, they're the exact same problems we're actively solving right now for our own green energy transition.
But look, advanced materials can't solve everything, right? We also have to talk about the human mind. Psychologists actually have a pretty chilling description for this specific kind of isolation. They call it a social ghost ship. This concept comes from the 2011 Mars 500 project, which was a 500-day simulation of a voyage to the Red Planet. Now, at first, things were great. The crew enjoyed each other's company. But by the return trip, after just 1 year trapped in extreme isolation with very limited space, the crew completely withdrew socially. Just extreme cabin fever. That psychological toll is a massive, massive hurdle when you're talking about people being permanently locked inside a moon base.
So how exactly did we go from these isolated, highly vulnerable little outposts to a thriving metropolis of 1 million people? Well, it was a pretty brutal learning curve. Let's look at the timeline.
Back in 1969, Apollo 11 was just a quick 21-hour stay. Then, in the 2010s, we got a huge game changer, the discovery of water hidden right in the lunar soil. 2026 hits, and the Artemis II crewed flight fires up humanity's big return. By the early 2030s, crews were basically just living inside their landing systems, which were essentially giant metal thermoses. But man, those early habitats were flawed. This incredibly abrasive lunar regolith, the moon dirt, it would get stuck in literally every gasket and hinge, causing these fatal decompression leaks. It really wasn't until mid-century, when we finally figured out how to construct massive regolith domes, that we paved the way for Luna Prime to safely hit 1 million residents by 2126.
Okay, let's actually dive into how they built those domes, because obviously you can't exactly FedEx cement from Earth. The brilliant solution was 3D printing moon concrete. Here's how it works. Step 1. Massive lasers target that highly abrasive lunar regolith powder. Step 2. The intense heat from the lasers melts the regolith down into a molten state. It's a process really similar to powder bed fusion. And then step 3. The material cools off and recrystallizes into an insanely tough structural ceramic. It's a totally ingenious architectural solution that allowed humanity to literally take the dangerous moon dirt and weld it into massive, heavily shielded domes. And those domes are what protect the city from solar wind and those sniper-fast micrometeorites we talked about.
But here's the thing. None of those amazing domes matter at all if you build them in the wrong spot. NASA's absolute geographical masterstroke was choosing to build at Shackleton Ridge down at the moon's south pole. By setting up camp there, they completely subverted the moon's absolute worst hazards. First off, they entirely avoided those deadly 14-day-long equatorial nights. Second, because of the location, the sun just sort of always hangs low on the horizon, giving them constant 24/7 solar battery power. Third, right next to all that sunlight are these incredibly deep craters that are shrouded in permanent darkness. And that darkness perfectly preserves ancient ice for drinking water. Finally, the specific angle of the ridge allows for a direct, uninterrupted communication link right back to Earth. It's literally the perfect real estate.
However, tapping into that frozen crater water, that requires sending actual machinery down into permanent, absolute cold. And that brings us right back to that dangerous day job I mentioned earlier. To keep the water mining machines from just freezing completely solid in the dark, the city relies on 95-year-old radioactive heater units filled with plutonium pellets. And inspecting these things, it is incredibly risky. If a unit breaches and you get a dose of radiation poisoning, or honestly, if you just slip on the ice and break a bone, you're in trouble. Medical treatment up here is pretty rudimentary. The triage center isn't exactly equipped like a state-of-the-art Earth hospital. Your prescribed treatment is essentially going to be get some rest, hope for the best, and maybe take a Tylenol.
Now, stepping away from physical safety for a second, let's talk about the sheer mind-boggling logistical nightmare of feeding 1 million people off-world. Just to put it in perspective, down on Earth, it takes about half to 1 full acre of farming space to feed just one person. Trying to do traditional agriculture on the moon, like walking around outside in spacesuits to tend crops, is ridiculously cumbersome and highly lethal. And you definitely can't just import your groceries. Back in 2026, a company called Astrobotic quoted a staggering $1.2 million per kilogram just to ship cargo to the moon. There's no way around it. The economics absolutely demand that the city produces its own food, and they do that through vertical hydroponics.
And the really cool part is that the biology actually backs this up. Inside these temperature-controlled buildings using artificial light, hydroponics, and low gravity turn out to be incredibly successful. We already know from older experiments on the International Space Station that things like leafy greens and peas grow really well. But the biggest breakthrough happened back in 2022, when Chinese researchers on the Tiangong space station successfully grew rice from seed to grain and all the way back to seed again. That was a massive biological victory. It proved that a place like Luna Prime can sustainably propagate its own seeds without ever needing to rely on million-dollar care packages from Earth.
Okay, so you've got food, water, and shelter totally secured. But now you have to manage the people. Luna Prime hosts all sorts of international factions. You've got the Artemis Coalition, China, India, Russia. But the geopolitics in the city are uniquely peaceful, entirely out of pure, unadulterated necessity. The golden rule up here is simple. Armed combat in space equals mutually assured destruction. If someone fires a single gunshot inside one of those domes, it immediately causes habitat decompression, explosive oxygen fires, and a total loss of life for literally everyone involved. The extreme lethality of the environment forces total, unconditional cooperation.
But as the city stays peaceful and entirely new generations of children are born on the moon, a new biological reality kicks in. Humans simply didn't evolve for low gravity. And this creates a massive engineering challenge. To keep the residents' bones and muscles healthy, the city has to use massive artificial gravity centrifuges, basically giant spinning rooms. Now, for ideal, comfortable livability, you need a centrifuge that's 1.5 kilometers in diameter, just slowly spinning at 1 rotation per minute. The theoretical minimum you could get away with is a 50-meter diameter, spinning at 6 RPM. But there's a huge catch. Spinning that fast in a tight little circle means your head is experiencing significantly less gravity than your feet, which leads to severe, constant nausea. So building these massive, comfortable spinning gyms and residences isn't just a luxury, it's an absolute necessity for survival.
So, living in Luna Prime means surviving in these tight, highly regulated quarters where, quite frankly, death is constantly waiting just on the other side of the wall. But the payoff? The payoff is the view. Because there's no atmosphere to scatter the light, night and day look exactly the same. You get a sky that is just always starry, always pitch black. And you can always just look up and see your tidally locked homeworld, Earth, hanging right there in the sky. It's breathtaking. And I think it leaves us with this final, really profound question. From this spectacular staging ground, how long will it take until humanity makes the leap to Mars, explores the rest of the solar system, and ultimately becomes a Type 3 civilization? It is an incredible future to imagine,